We are going to start our review of Unit 3, Quadratic Relations, by looking at how to graph a quadratic relation. And once they are graphed, we call those shapes parabolas. And we are going to be using the vertex form of a quadratic relation to graph. So what we want to do before we actually graph is we want to gather information from the quadratic relation. So we're going to start off with A, which is y is equal to x squared. So y is equal to x squared. This is our basic parabola. And our basic parabola has a vertex at 0, 0. So we're going to plot that vertex at 0, 0. And then we are going to use what we call the step method. So that's already written over here at the side. So the step method to plot 2 more points on each side of the vertex. So for the vertex, our A value is 1. Let's just look back up here to our vertex form and see where A is. So our A value is 1. So that means that when we plot using the step method, we're going to go over 1, up 1, and then plot a point. And then we're going to go over 1 and then up 3 and plot a point. Now, if we have space, we can go over 1 again and then up 5. We don't have space on this grid. We're going to do the same thing on the left-hand side of the vertex. Over 1, up 1, plot a point, and then over 1, up 3, plot a point. So we're always building on the previous point. Now that we have 5 points, because we should always try to have 5 key points for every parabola we graph to see the shape, we're going to do a smooth curve through those points. We're going to extend our curve past the last points, and we're going to put an arrow on the end to show that that curve continues. Okay, so that is Parabola A. Now let's do Parabola B. So the vertex for Parabola B is at +3 and -6. So notice that the x-coordinate of our vertex right here has the opposite sign of what we see in the brackets. Okay, so we see a -3 in the brackets, but our x-coordinate of the vertex is a +3. So we are going to start out by plotting that point. Okay, so +3, so we start at 0, 0, we go right 3, and then we go down 6. Okay, we've plotted our vertex. Now, for this relation, or this equation for this relation, our A value is 1 as well, so our step method stays the same as before. So we go over 1, up 1 point, over 1, up 3 point, and in this case we have room to do another one. So over 1, up 5 point. And we do the same thing on the left-hand side. Over 1, up 1 point, over 1, up 3 point, and over 1, up 5 point. And we're going to draw a smooth curve through our points and extend past those last points and put an arrow on the end. Okay, we should label that as B. Let's go to C now. So for C, our A value is going to be -2, and that is going to affect our step method. But we are going to start out with plotting the vertex first. So our vertex is at -5 and +3. So again, the x-coordinate has the opposite sign of what we see in the brackets. Okay, so let's plot that point. So -5 and then +3. So we can look at the equation and gather the information for the vertex. We also see that we're going to have to calculate a different step because our A value is not 1. And the negative sign in front, so here we have this -2, this means that our parabola opens downward. Okay, so the two we've done so far open upwards. This one opens downward. So that means when we do our step, we're not going to be going up, we're going to be going down. First, though, we need to calculate our new step. So I've set up a little chart here on the right, and we're going to calculate our new step for when A is equal to 2. So we have 1 times 2. So we use the basic step, so the 1, 3, 5, and then we multiply it by our new value for A. So 1 times 2 gives us 2, 3 times 2 gives us 6, and 5 times 2 gives us 10. So this means our new step, instead of being 1, 3, 5, is 2, 6, 10. So we're going to go back to our vertex here at -5 and +3. And remember, this is opening down. So when we do our step, we're going to go downwards instead of upwards. So we're going to go over 1. So we always still go over 1. It's going to be the other part of the step that changes. So over 1, and now we're going to go down 2. Over 1 and down 6. And if we had more space, we'd go over 1 and down 10. Let's do the same on the other side of the vertex. So we're going to the left this time. So over 1, down 2 point, over 1, down 6 point. We draw a smooth curve through our points, and we label our graph. And lastly, we have D. So D is y is equal to 1/2 of x squared plus 4. So what we need to do here is we need to recognize again that our A value is not 1. So we're going to have to calculate our new step. And let's, before we do that, determine our vertex. So our vertex in this case is at 0 and +4. Now we know that the x-coordinate is at 0 because there's no brackets with a number and x in there together. Okay, so we know that we're not going left or right for the x-coordinate. We're just going to be going up 4 when we are plotting the vertex. So let us plot the vertex, and we might have some overlap here, so I might use a little x. So our vertex is, maybe I'll even use a different color. Let's use red. Our vertex is right here. Okay, and now let's also calculate our new step. So A is 1/2, and you can, if you're doing this on your calculator, 1/2 is the same as 0.5, right? So you can just punch in 0.5 in your calculator, and I think I'm going to write it as 0.5 here because it'll make it easier than dealing with the fractions. So 1 times 0.5 gives us 0.5 or 1/2. 3 times 0.5 gives us 1.5. And 5 times 0.5 gives us 2.5. So these are our new steps, 0.5, 1.5, and 2.5. So we go back to our vertex here at 0 and 4. And we're going to go over 1 and then up 1/2. So I'm going to put a little line instead of a point just for spacing. Now after this half, we go over 1 again, and then we go up 1.5. And we put another point there. So we don't have space to go over and then up 2.5. But that's okay because we'll still end up with 5 points in total. We're going to do the same thing on the other side. So on the left-hand side, we go over 1, up 1/2, put a point, over 1, and then up 1.5, put a point, and we're going to draw our curve smoothly through those points. And we should label this D. Next, we're going to identify parts of a parabola from a graph. So we have our graph up here, but we also have the equation. So we're going to be using a little bit of both, and I'm going to flip back and forth. So I'm actually going to amend this. So it says from a graph, or from the, or I'll just say relation, or from the relation. There we go. So let's take a look here. So we did the vertices already. So vertices is plural for vertex. We did identify the vertex from each of these different parabolas here. So let's write that down. So for y is equal to x squared, we identified 0, 0. Y is equal to x minus 3 squared minus 6. That's going to give us positive 3 and negative 6. For C, we have negative 5 and positive 3. And for D, we have 0 and 4. Now, at this point, if you have not reviewed the notes for the unit and the parts of a parabola, then you should go back and review those, where we go over all this different terminology in some detail. So next up, we have axis of symmetry. So the axis of symmetry is a point, and I'm going to show you on B right here. So axis of symmetry, is not a point, is a line that goes through the vertex, okay? So it's a vertical line going through the vertex. So the axis of symmetry is actually written as an equation. So in the case of y is equal to x squared, it'll be x is equal to 0. And it relates back to this number right here. So those two numbers should match up. So we're going to see that for the axis of symmetry for B, C, and D. Okay, and I'm going to underline those numbers as well so you see where they match up, because we'll be looking at some other matching numbers in a moment. So direction of opening, this is whether it's opening up or downwards, and that's fairly self-evident from the from all of the parabolas. If we look back up here, we only have C that is opening downwards, and for C we have that negative sign right out there in front, and that tells us it opens downwards. So you can write upwards or downwards or just up and down. Oops. Okay, lastly, we have maximum or minimum and point. So the maximum or minimum is related to the direction of opening. So if something opens up, it has a minimum, and we're just going to write min. Okay, for all of those that open up, we write min. Now, there is a maximum, so a highest point, if it opens downward. So for C, this is the only one that opens downward, so it has a maximum. Now, we're also asked to do the point. So this point is a y coordinate, because the y gives either like the highest or the lowest, and it's going to be the y coordinate of the vertex. So for our first one, we have y is equal to 0, right? And this is going to align with the y coordinate of the vertex there. Our second one, we have y is equal to negative 6. Our third one, we have y is equal to positive 3. And our fourth one, y is equal to positive 4.